Hello everyone, welcome back to the fast track revision series of UGC NET Electronic Science. In this video, I want to discuss two very important miscellaneous points which I have not discussed in regarding flip-flops, regarding the concept of flip-flops. Okay, if you are first time to my channel, please consider subscribing and don't forget to hit the bell icon to get video notifications from my channel. Right, so those two concepts are the first concept is asynchronous or direct inputs. Okay, asynchronous inputs or direct inputs of flip-flop. This is what I want to discuss, right? Because we'll use these concepts when we discuss about counters, modulus counters in particular. Okay, so flip-flops, right? Any flip-flop, if you take any flip-flop like SR, JK, T, D, every flip-flop, suppose I'm taking SR flip-flop for example. Okay, so this is clock pulse, this is Q, and this is Q bar. Okay, so when it is available in IC form, okay, so when flip-flops which are normally available in IC form, right, so it will have two more inputs which are called preset bar and clear bar, because they are active low inputs. Okay, so we are representing with preset bar and clear bar because they are active low inputs. So there are two more inputs available in IC form. Okay, when flip-flop is available in IC form, you have two more inputs. So what is the importance of these two inputs is, so first point which you have to remember is SR. In SR flip-flops, the inputs S and R. JK, that is in JK flip-flop, the input JK, T, D, in T and D flip-flops respectively. So all these inputs are said to be synchronous inputs. Synchronous inputs of flip-flop. All these inputs are synchronous inputs of flip-flop. That is, they are synchronous with respect to clock. They are synchronous with respect to clock. So based on the clock pulse only, you can apply these inputs. Okay, suppose it is negative edge triggered flip-flop. So if the clock is there here, suppose at this negative edge triggering, you are given with S is equal to 1 and R is equal to 0. That is setting, and at other negative edge only you can change the input. S is equal to 0 and R is equal to 1. So in between, if you want to change the input, or if you want to, so this is set, right? So Qn plus 1 is equal to 1. So in between here, you want to make Qn plus 1 is equal to 0, right? So you can't make directly, right? So you can't make this directly because all the inputs are synchronous with respect to clock. That is called synchronous with respect to clock means. So according to clock pulse, that is according to the negative edges only, if it is negative edge triggered flip-flop, according to the negative edges of the clock only, you are going to change the input so that you are going to get the corresponding change in the output. This is what happens in synchronous inputs. But if you want to make the output of flip-flop with 1 or 0, if you want to make the output of flip-flop either 1 or 0, even in between the edges, corresponding edges, negative to negative edge or from positive to positive edge, so we are going to use these inputs, preset and clear. That is why these two inputs are very important. So if you make a preset bar, because this is active low, so if you make preset bar is equal to 0, so 0 given to a NOT gate, like NOT gate, so it will become 1 again, so it will be high, active high. So when preset is given with 0, then you can make qn plus 1 is equal to you can set this qn plus 1 is equal to 1. So in the name only the preset. So if you want to set, so you can give this as 0, and if you want to clear it, so that is clear bar is equal to 0. If you are given with clear bar is equal to 0, then qn plus 1 is equal to 0. So when you are given with preset is equal to 0, in this condition what you have to give, clear bar should be given with 1. So if you are using clear bar is equal to 0, so in this condition preset must be given with 1, so that they will be in active low, so they will be not activated. Okay, so this is the advantage of preset and clear. So when you are given with preset is equal to 0, when we are given with asynchronous inputs, if asynchronous inputs are made high, then remember this point, synchronous inputs loses its importance. Synchronous inputs loses their importance. That is, irrespective of S and R in, suppose if you are taken with SR flip-flop, so irrespective of S and R inputs, if you make preset is equal to 0, then output is equal to 1. Even if you give reset condition also, S is equal to 0 and R is equal to 1, so even if you give reset condition also and you have made preset is equal to 0, then output is always equal to 1 only. Even in this case also output is equal to 1. So asynchronous inputs have higher priority when compared to synchronous inputs. Okay, so this is the important point which you have to remember. Second point which I want to tell you is output frequency of T flip-flop. Okay, so output of frequency of T flip-flop is input frequency by 2. Okay, so it is divided by 2 frequency divider. Okay, so output frequency of T flip-flop is input frequency by 2. So it is obvious when T is equal to 1. So this is possible only in toggling mode. So when T is equal to 1. So when T is equal to 1, suppose initially Qn is equal to 0. So when you are given with T is equal to 1, so what will happen? Qn plus 1 first becomes 1. And again, in order to become it equal to Qn, so it will take another clock period. Right? So for the first clock period, Qn plus 1 becomes 1. For the next clock period also, if you make T is equal to 1, then for the second clock period, Qn plus 1 becomes 0. So in order to have the same input, it requires 2 clock cycles. So in order to have that T output same as input, it requires 2 clock cycles, 2 into Tn. So when it requires 2 Tn, then if you want to convert this into frequency, so if time period is doubled, what will happen to frequency? Frequency is halved. So it becomes half. And time period becomes double, because time period is inversely proportional to frequency. When time period doubles, frequency gets half. So output frequency of T flip-flop is always equal to input frequency by 2. Okay, suppose input frequency is 10 kilohertz. They may ask you very simple question, right? So 10 kilohertz by 2, so you'll get 5 kilohertz as the output frequency. Okay, so these two concepts please keep in mind. So these are also very important and you should know about this. Okay.